This do now can really help you with today's main topic of adding and subtracting polynomials. The do now really has you hopefully figure out the difference between what you would do when you simplify within one term, like problems number 2 and 7, which we learned back in February, versus simplifying more than one term, which is our new content, like numbers 4 and 6 and 8 and 9. All right, so let's get to it. So in number 1, you've seen this problem for years. X plus x, you would say, is 2x. So you are combining like terms there, and x are like terms because they both have a base of x raised to an exponent of 1. And like I said, it would be 2x. So we're showing our quantity of how many x's we have through the coefficient, which is 2. Notice here that the exponent did not change. The exponents of x in our problem are 1 and 1, and essentially we do have a 1 there. We just don't usually write it in. So our answer is 2x. Now, this is very different than number 2. Number 2, you're simplifying repeated multiplication, so you're simplifying within one term, x times x times x. A quicker way of saying that is to write x to the third. So a quicker way of writing repeated multiplication is to use a power, whereas to simplify repeated addition, we're using multiplication. In number 3, we have like terms. X, and 2x are all like terms because they all have the same base of x raised to exponents of 1. And if I really wanted to show how all of these are like terms, I could expand out x plus x, which can't be expanded out anymore because they each have 1 x. And then 2x tells me I have 2 x's added together because 2 times x, that multiplication, is really short for repeated addition. And therefore I have 4 x's added together. You can see here. Now 4 x's added together, that's repeated addition because every term is exactly the same. They all have an x and they all have an exponent of 1. So I have 4 x's added together, which I can write as 4 times x. For number 4, again, we're simplifying by combining like terms. And the like terms we have here are an x squared and a 4x squared. So let's actually, I want to expand this out for you. So down here, I'm going to write, I just don't have room up there, x squared plus, and you write this underneath your problem, I just don't have room. So we have an x squared and then 4 times x squared. That multiplication between the 4 and the x squared, that's really short for repeated addition. So 4 times x squared is 4 more x squareds added together. And then I have a plus x. So I can see that my first 5 terms are repeated addition because they're exactly the same. They have the same base raised to the same exponent. So I have 5x squareds added together, and a quicker way of writing repeated addition is to use multiplication. 5 times x squared. And then the x is not a like term because it's not exactly the same as my first 5 terms. So it's just a plus x gets added on. And that's all simplified because all my like terms have been combined. Number 5 is similar to number 2. We're simplifying within one term. So for number 5, we have negative 2 x squared times x, and that would be negative 2 x to the third. And that's like your problems that you learned back in February, because x times x is x squared, and then we have that additional x, and that's what gives us x to the third. We have 3 x's multiplied together, and that's the same thing as x to the third. Number 6, we have like terms that need to be combined because both of those terms have a base of x raised to the same exponent of 2. Now the sign tells me what type of x squareds I have. I have 5 negative x squareds. And that coefficient tells me how many I have. So I have 5 negative x squareds. And again, you write this under your problem, I just don't have room. And then I have 2 times x squared, which is plus x squared plus x squared. And the negative x squared and the positive x squared cancel out. And I can see I have 3 negative x squareds remaining, which I'm just going to write as 3 negative x squared. So again, just like the other problems where we were combining like terms, our exponents don't change when we combine like terms. We're showing our quantity through the coefficient. And that's different than problems, 2 and 5, where you're simplifying repeated multiplication. You are changing your exponent in those cases. For number 7, it's back to a problem like numbers 2 and 5, where we're simplifying within one term. So we have 5 times 6 is 30. X to the third times x to the fifth. That's 3 x's multiplied together. Next to 5 more x's multiplied together. 1, 2, I think I wrote 1 too many. Here we go. Yeah. And that would give us 8x to the 8th. X to the 8th, I should say. Number 8, we have some like terms because the first 2 terms have bases of x raised to the same exponent of 5. Negative 4x to the 5th plus 6x to the 5th, that's 2x to the 5th. So when I combine like terms, my exponents stayed the same. And I'm just showing my quantity through the exponent. And then I have a plus 3x squared. And I'm done. Number 9, I'm combining like terms. I have 8x squared plus 7x squared. We know 8 times x squared is really 8x squareds added together plus 7 more x squareds added together. That's 15x squareds added together, which I can write in a quicker way as 15 times x squared because multiplication is short for repeated addition. Number 10, we're simplifying within one term, so we're simplifying repeated multiplication here. 8 times 7 is 56. X squared times x squared is x to the 4th. All right, so the big takeaway from this do now is that for problems like number 1, 3, 4, 6, 8, and 9, when we combine like terms, we showed our quantity of how many, x's or x to the fifths we had, whatever the case was. We showed that quantity through the coefficient. We did not change our exponent. And it's only when you're simplifying within one term and you're simplifying repeated multiplication that you change the exponent. But when you add and subtract polynomials, I want you to think about problems 1, 3, 4, 6, 8, and 9 when you're combining those like terms. Thank you.